Okay, 1.1 homework, domain and range. Given the graph or ordered pairs of each relation, state the domain and range. Okay, so for the first graph, what we want to do for domain is we want to take a look at where the x, like quote unquote, starts. Okay, so the x starts at -8, this number right here, and these numbers here, it's going this way, they are increasing. So what we do is we do x is an element of the real number system such that x is greater than or equal to -8. Okay, now the range. Same idea. The y value, so remember this is the x-axis, this is the y-axis. The y value starts at this -2, right? So this is like our starting point, and then our graph goes up. So y is an element of the real number system such that y is greater than or equal to -2. I'm going to delete numbers. Okay. B. So for the domain, you can kind of memorize this, but the domain of any parabola is XER. Okay, so x is an element of the real number system. What happens is these arrows imply that it goes left, like it looks like it's going very slowly, but it is going left forever and ever, and it goes right forever and ever. So essentially, you can plug in any number of x, and you can still get an output of y. Okay. The range is a little bit different. What we want to do is we want to find the max or min point. So with a parabola, I see that this is going to be -7. And then we have to decide whether it opens up or down. So this definitely opens up. So we kind of start at -7 and we go up. So y is greater than or equal to -7. Okay, and then this is like half a circle. So this goes from, like on the x-axis, this goes from -5 and it goes all the way to 5. So simply the domain is going to be x is an element of the real number system such that x is between -5 and 5. Okay, and we can set up the y's as well. So the y, the smallest number for y is here, it's -3, and the biggest number for y is 2. So y is between -3 and 2. Okay, so for D, when we're talking about domain, we're talking about the x values. So this is a continuous function. You don't have to pick up your pencil in order to draw this. So we go from -3 to 0. Okay, so the domain is x is an element of the real number system such that x is going to be between -3 and 0. Okay, and I'm just setting up my y. So for range, we go up and down, right? We want to talk about the y-axis. So the smallest number is going to be -2, and it's going to be drawn up to 3. That's going to be like the biggest number here. Okay, so y is an element of the real number system such that y is between -2 and 3. Okay, E, I'm going to treat this as though it has arrows on it. I know that some graphing software doesn't put arrows, so I'll treat this as arrows. This is going to go left and right forever. So domain is just simply XER. Every single number that exists in the world, every real number that exists, it's going to plot on. Okay, now y is an element of the real number system. Here's the thing. So y, the lowest y value is -16, and then the graph goes up forever. Okay, the graph doesn't exist down here. We call it undefined, right? The graph isn't defined down here. So we can just simply say y is greater than or equal to -16. Okay, E, F, and then this is F. So this is a function. This is the 1 over x function. Okay, it's called the rational function. And we're just introducing this right now. So a rational function, just remember a rational this is a fraction, right? So there's going to be 2 asymptotes. So it looks as though that the horizontal asymptote is at y equals 0. Okay, and it looks as though the asymptote here, I want to almost say that it's at x equals 1. Okay, so if we take a look, the x is never going to hit 1. So the domain is going to be XER such that x doesn't equal 1. It's going to hit every other x value except for 1. Okay, and y is an element of the real number system such that y does not hit 0 ever. Okay, so y is never going to be plotted at 0. Okay, so for G, it's a little bit different because this is discrete. Okay, and remember, discrete is usually in the form where it just lists numbers. So for domain and range, we're also just going to list the numbers. So we can say x is an element of the real number system such that x equals, and then we literally just list the numbers 3, 2, 1, and 5. What we want to do is we want to put those in order from smallest to largest, just to keep proper math form. Okay, and the y's are 2, 2, 2, and 2. Oh, that's easy. You do not have to list that multiple times. Okay, one other way that you could see this written, so I deal a lot with a real number system, so real number system. Another system that you could deal with is the integer number system. Okay, system. What does that look like? So when we talk about integers, we talk about like pretty numbers. Okay, pretty numbers. And this is both positive and negative. So when we're, you know, like in elementary school, when we do a number line and it's 0, 1, 2, 3, -1, -2, -3, and everything's a really nice number, these are integer values. So sometimes what students can do, if you choose to, is you can say that x is an element of the integers. So since we have 1, 2, 3, and 5, you could potentially say x is between 1 and 3, and then comma and 5. The other way that you could do it is you could say x is between 1 and 5, and x does not equal 4. And what that does is, because you've specifically said, I'm talking about integer values, well, it doesn't make this continuous with real number system. It makes it only the integers between 1 and 3. So the integers between 1 and 3 are 1, 2, and 3. The integers between 1 and 5 are 1, 2, 3, 4, and 5. Okay, so if you did 1 to 3, you also have to include the integer 5. If you did 1 to 5, you have to then take out the 4. Okay, a little bit more accurate, just like math form wise, but a little bit more complicated if you're not using the integer number system often. Okay, and then the range is going to be the same. You can say y is an element of the integer number system. Let's go such that y equals 2. It's still going to be the same because there's only one value there. Okay, we're going to do number 2. I'm going to give myself a little bit more room. Okay, so number 2 is a little bit different because it doesn't give us something concrete to look at. It just gives us equations. So you have to kind of know what these equations, like what these graphs look like. Okay, so 2a, and I'm just going to put it down here. I'll just label them. Okay, we have y equals -3x plus 7, and we just have to state domain and range. So this is a line. We know that. Okay, if you wanted to graph this, you know what it looks like. The y-intercept is 7. And then the slope is negative, so it's going to be going down, something like that. Okay, but we know for every line, x is an element of the real number system. and y is also an element of the real number system. Okay, B. So we have y equals negative 4x squared plus 3. This is a parabola. Okay, and this is technically in vertex form because if you took that as x, it'd be like x minus 0 squared. And obviously x minus 0 just cancels, like simplifies to x squared. So essentially the vertex is 0, 3, and this opens down. So if you did want to graph this, 0, 3, and it opens down like this, okay? So with a parabola, every single domain is going to be, XER, no matter what, okay? And as for the range, we want to look at this k. So remember, this is like h comma k. So we want to look at this k value, which is 3, and we're going from 3 and we're going down. So this one's a little bit different than what we've seen. Y is going to be less than or equal to 3. All right, C. So C is our new function. It's going to be like the 1 over x. Remember, rational function. So whatever this number is, like say it's x plus 6, we would solve, and we're going to have a vertical asymptote at x equals negative 6. So what this looks like, and we haven't studied it yet, but there's going to be a vertical asymptote at negative 6, and there's going to be a horizontal asymptote at 0. And then we're going to have two parts of this graph, two asymptotes, so lines that the graph approaches infinitely and like gets infinitely close to, but never actually touches. Okay, so how we set up this domain and range is that we say x is an element of the real number system such that x does not equal the negative 6. Negative 6 being this vertical asymptote here. And we set up the range the same way, whereas the y does not equal the horizontal asymptote, which is 0. And we're going to study that a little bit more. As of right now, you most likely don't know how to graph this independently, and that's okay. All right, D. That's better. D, again, a parabola, and the vertex is at 1, 4, and it opens up. Okay, so parabola vertex is 1, 4. Let's just plot the vertex there, and it opens up. Okay, domain, we don't even have to think. For parabola is XER. For range, we have to say y is an element of the real number system such that we look at this k value, so it's 4. So we're going to compare it to 4, and it opens up. So y is greater than or equal to 4. Okay, E. So this equation here, what we'd have to do is we'd have to, for like the 2x plus 1 under the root sign, we're dealing with the root function, okay? So this root x is either called a root function or it's called a radical. Radical is like another name for root. So in order to actually read this, we have to common factor out this 2. This is going to be a theme in this course. We're, again, going to get more into that. So 2x plus a half. Okay, so in other words, I call this the fake vertex, but we're going to have a radical function, and it's going to have like that vertex of negative 1/2 and then 0, okay, because it's plus 0 on my end. So it's going to go negative 1/2, 0, it's going to start here, and it's going to go like this. Okay, so for the domain, we're going to start with this number here. So x is an element of the real number system such that we're going to start at negative 1/2, and the x values are going to increase. X is greater than or equal to negative 1/2. Okay, now y is an element of the real number system such that y is greater than or equal to 0. Because again, we start here, which is 0, and we go up. And it doesn't look like it because it's going up very slowly, but this goes up forever. Okay, and now f. F is a circle with radius, this is a circle, radius 6, right? Because we root that number there. So this is f. We're doing a circle, it's centered at 0, 0. So radius is 6. So we have 6 and 6, negative 6, negative 6. Okay. This one's quite easy. I find that students like this one. It's simply x is between two numbers and y is between two numbers. What numbers are these? Negative 6 and 6, negative 6 and 6.